All right, let's look at the critical points. Right. So when you look for relative max or relative minimum, you want to look at the certain places. In a function of one variable, we look at the critical numbers, right? So where the derivative equal to 0 and the derivative is undefined. All right, so we want to be able to define critical points for a function of two variables. All right, so here's the definition. It's actually quite similar to the function of one variable. All right, so point x comma out a comma b in the domain of the function f is called a critical point of f if one of the following is true. Right? So since it's a function of two variables, we have to look at partial derivatives. So partial derivative with respect to x and the partial derivative with respect to y at a comma b is equal to 0. So that's one kind. Another kind is partial derivative is undefined, or with respect to x is undefined, or it could be both. Partial derivative with respect to y is undefined at a comma b. Then it is called the critical point, right? All right, so let's look at one example for each case, right? So here's an example. You have a f of x comma y equals 2x squared plus y squared plus 8x minus 6y plus 20. All right, so let's try to find a critical point. All right, so first we need to take the partial derivative with respect to x. All right, so partial of that with respect to x would be 4x. All right, partial of y squared would be 0, and the partial of 8x would be just 8. And a partial of 6y and a 20 are both 0, right? So we set that equal to 0. And you can see that you can just solve for x. So you subtract 8. So you have 4x is equal to negative 8. And then we can just simply divide through by 4 to get x is equal to negative 2. Right, so that's the x coordinate. All right, so we take the partial derivative of f with respect to y. Right, partial of the first term is 0. Partial of y squared with respect to y is 2y. And partial of 8x with respect to y is 0, since it's a constant. Partial of negative 6y would be negative 6. And a partial of 20 is, of course, 0. So we set the partial with respect to y equal to 0. Then we can solve for y. Right? So we can add 6 to both sides. So you have a 2y is equal to positive 6. Then we can simply divide through by 2 to get the y is equal to 3. Right? So we found the critical point. So critical point would be, right, so x is equal to negative 2 and y equals 3. Right? All right, so let's look at what the surface look like at this critical point. I'm going to open up a Geogebra. All right, so we need a different window. So go to Views, and we're going to have 3D graphics. And then you can just close this one, the 2D one. All right, so we have that. All right, so let's type in the function here. It was z is equal to 2x squared plus y squared plus 8x minus 6y plus 20. All right, so it looks like that. So let's see. See if we can. Right, so it looks like that. So it looks like a cup, right, floating in the air, right? So if you see the point 2 comma 3, so maybe I may be able to put that in. Let's see. I don't know if this works. You have negative 2 comma 3, and so comma f of. I don't know if this works. I'm gonna try negative 2 comma 3. Right. Oop, it doesn't work. All right, so let's see. All right, so negative 2 comma 3 is the here. This is the critical point, but if you go up here, so that would be, looks like you're going to have a relative minimum right there. All right, you can see that. All right. So this example, it looks like a cup floating in the air, and the critical point is right here, and which is right below this relative minimum. All right. All right. So let's look at the let's look at another example. All right. So this is the other kind. So partial derivative is undefined. All right, so we have this function f of x comma y, which is equal to 1 minus quantity x squared plus y squared to the 1/3 power. All right, so let's take the partial. All right, so we take the partial derivative with respect to x. So partial of 1 is 0. There's a negative sign. All right, so you put the 1/3 in front and keep the inside as it is. All right, I'm just doing the chain rule and subtract 1, so it's a negative 2/3 power. And then chain rule multiplied by partial of inside with respect to x is 2x. All right, so if you want, we can rewrite it to make it look a little bit better. So you can see, maybe I'll put it here. So there's a negative sign in front. All right, there's a 2x, so put it up here. And then there's a 3 there. Right? Since this has a negative power, I'm going to put x squared plus y squared to the 2/3 power on the bottom. All right, it looks like that. All right, so we have the partial, so we're going to set that equal to 0. All right, then here, so it looks like in order to make that equal to 0, x equals 0. All right. And let's look at the partial with respect to y. All right, so here, so it's going to be the same thing. Partial 1 is 0, partial of that is negative 1/3. It's almost exactly the same, except that when you do the chain rule, since you're doing the partial with respect to y, so it's going to be 0 and 2y. Right? So it's going to look like negative, right? And there's 2y, and there's going to be 3 on the bottom, and the quantity x squared plus y squared to the 2/3 power. If you set that equal to 0, we just set the numerator equal to 0, so y equals 0, right? All right, so it's very tempting to say that 0 comma 0 is the critical point of the first kind, right? Because we set the partial derivative equal to 0. But we have to look a little bit more carefully. All right, so you can see that at the 0 comma 0, the partial derivative actually does not exist. You can see that if you put x equals 0 and y equals 0, then denominator becomes 0. So at the origin, partial derivative with respect to x and the partial derivative with respect to y are both undefined. So we say partial with respect to x at 0 comma 0, and also partial with respect to y, 0 comma 0, are in this case both are undefined, right? We don't have to have both, but in this case they are. All right, so this indicates that this is the origin, 0 comma 0 is a critical point of the second kind. So maybe I'll just say critical point of the second kind, so 0 comma 0, where the partial derivatives are undefined. All right, so that's the critical number. All right, let's see what it looks like on GeoGebra. All right, so we have z is equal to 1 minus quantity x squared plus y squared raised to the 1/3 power. All right, so we have that. All right, so you can see that here, right over the origin, so origin's up here, so you're going to go straight up. So you can see there's a pointy top here, right, tip, so right here. All right, so you seems like we're going to have a relative maximum there. So this is a relative maximum point. And the reason why partial derivatives do not exist is that you can see that you can kind of think two-dimensionally. You can see there's a sharp corner here or cusp. All right, when you have that, the derivative doesn't exist. So in this case, you have a sharp corner in x direction and also a y direction. So that's why at 0, 0, the partial derivatives are undefined. All right. All right. So that's the definition of critical points. All right. That's it. I hope that this was clear.